So now it's my pleasure to introduce Lizzie Brickley, who came to us from London. Lizzie is a professor in the Department of Infectious Disease Epidemiology and International Health at the London School of Hygiene and Tropical Medicine, where she also directs the Health Equity Action Lab, which is an interdisciplinary team that examines the links between human health, poverty, and the environment. Please welcome Lizzie.
Hi, everyone. Thank you so much. I'm delighted to be here with you today and to have the opportunity to tell you a little bit about Dartmouth's truly remarkable contributions to the global polio eradication efforts. Polioviruses are single-stranded RNA enteroviruses that replicate in our oropharynx and ileum in the small intestine. They're therefore transmitted via oral-oral and fecal-oral routes, including contaminated water, such as rivers. Humans are the natural hosts and sole reservoir of polioviruses, which makes them a prime candidate for eradication. But one challenge for us is that we have 3 distinct serotypes of polio with limited heterotypic immunity. And this means that we have to really think about eradicating all 3 of these serotypes of polio. When someone is infected with polio, we'll see that around 70% of those infections will be asymptomatic. About a quarter of them will progress to a minor illness that can be kind of flu-like with fever, fatigue, headache, sore throat, and GI symptoms. 4% will develop a non-paralytic poliomyelitis, which can include 2 to 10 days of stiffness or pain in the limbs, the neck, and the back, severe headaches and vomiting, and less than 1% will develop paralytic poliomyelitis, which we also know as polio. Now, polio is a rapid onset flaccid paralysis, which is irreversible, although some partial recovery is possible. Polio infections can also progress to death. And the main reason for this is because it can cause the immobilization of our breathing muscles. So in 1946, Time magazine reported that this year, thanks to the early recognition of the disease and improved treatment, iron lungs, physical therapy, et cetera, the death rate is down to 5%. And what's really striking to me is that despite all of the progress that we've made, we continue to see a very similar case fatality rate today. Now, polioviruses are ancient viruses, and they've been infecting children for millennia. Nevertheless, epidemics of polio disease were virtually unknown until the 20th century. Traditionally, what happened is that infants were exposed and infected at a very early age, typically in the first year of life, but they were protected from severe disease due to the presence of their maternal antibody. All of this changed in the 19th century with our changing epidemiological landscape through improvements to sanitation and indoor plumbing. And so with this, children's first exposures occurred later in life in the absence of maternal antibody, which left them susceptible to paralysis. And if we look at the bar chart on the right here, we can see the emergence of the first outbreak of polio in the United States. And this is where Dartmouth's connection to the polio story really begins. And the reason for this is that the first cases in the United States emerged just down the road in Rutland, Vermont. And through shoe leather epidemiology, a young physician by the name of Charles Calverley, who was also Dartmouth class of 1878, carefully documented 123 cases and 18 deaths, which mostly occurred among children residing near the river. Charles described it as by saying, "This region has been affected by an epidemic of nervous disease very rarely observed." He also very critically helped to establish one of the first epidemiological links that we have to polio. Now, similar epidemics emerged in Europe and then began to return to the United States every summer. By the 1950s, more than 50,000 cases of paralytic poliomyelitis were reported annually in the United States. And this brings in another really remarkable Dartmouth alum, Basil O'Connor, Dartmouth class of 1912, who really recognized that there was a need to fundraise the fight against polio. So Basil O'Connor was a law partner of Franklin Delano Roosevelt, and he founded what we now know as the March of Dimes, raising critical funds for the treatment and rehabilitation of children with polio. And also, and very importantly to this conference, research including Jonas Salk's pioneering vaccine research. And what this resulted in was the inactivated or killed vaccine, which we call IPV, inactivated polio vaccine, which was developed by Jonas Salk in 1953. It's a vaccine that's administered by injection and provides robust protection against paralysis. With IPV, annual cases of polio in the United States dropped from more than 50,000 in 1952 to only 161 by 1961. But I think what's particularly salient today is that this was a real early model for vaccine equity. So when questioned about who owned the patent for IPV, Salk answered, well, the people, I would say. There is no patent. Could you patent the sun? At the same time, there was a parallel effort that was ongoing by Albert Sabin to develop the oral live attenuated polio vaccine that we call OPV. And so this was developed in 1954. It was more easily administered by using oral drops or on a sugar cube. And like IPV, provides robust protection against paralysis, but it also confers additional benefits. So it can spread the vaccine virus to susceptible contacts and interrupt our chains of transmission. OPV became commercially available in 1961 and soon supplanted IPV as the primary polio vaccine in the United States. By 1979, the United States eliminated polio using OPV in routine immunization. But despite OPV's many benefits, a key limitation is that in very rare cases, it can cause vaccine-associated paralytic poliomyelitis, what we call VAP. And so this occurs approximately 1 case of VAP per 750,000 doses of OPV. And if you look at the chart on the right, we'll look at the cases of paralytic poliomyelitis in the 1980s. And in the yellow, you can see the non-VAP cases, so those caused by wild virus, and the red indicates the VAP. And so under this epidemiological scenario, the risks of VAP began to outweigh the benefits of OPV in this post-polio United States. And so this is where another important Dartmouth figure comes into play, and this is John Maudlin, who's a Dartmouth Emeritus Professor and former chair of pediatrics. And John Maudlin was really instrumental in leading clinical trials of high-potency IPV that led the way for the US to transition from an OPV-only vaccination schedule to a sequential schedule of IPV and OPV that eliminated the risks of VAP while still conferring robust protection. More recently, John has made truly remarkable progress for global polio eradication through his work at the Bill and Melinda Gates Foundation, working on the development of the novel oral polio vaccine type 2, which is more genetically stable than the Sabin OPV. So given the wins in some countries in terms of eliminating polio, in 1988, the World Health Assembly passed a resolution to eradicate polio worldwide. Ultimately, OPV was selected as the primary tool of the Global Polio Eradication Initiative. And since that time, worldwide incidence of polio has declined by greater than 99.99%. And in September of 2015, the WHO certified the eradication of wild poliovirus type 2. And in fact, the man who's holding the trophy on the right also is Hamid Jafari, and at the time was the leader of the Global Polio Eradication Initiative, and is also did his residency here at Dartmouth. So another amazing connection. In October 2019, the World Health Organization certified the eradication of wild poliovirus type 3. And so that leads us to today. And so if we look at the last year, so going back to November 2022 to the 31st of October 2023, we can see that we only have 10 cases of wild poliovirus type 1 that have been reported in a very limited geographic area in Afghanistan and Pakistan. So as we move now towards this kind of end game of polio, we hope, we still have a lot to learn, though, about understanding this vaccine-induced mucosal immunity and really thinking through the mechanisms of how we can use these vaccines best. And so using polio as a case study, Peter Wright has led an interdisciplinary team at Dartmouth, including many in this audience, and so Ruth Connor and Margie Ackerman and others, in trying to understand how we can use vaccines to induce immunity that not only protects individuals, but also interrupts viral transmission. What this work also does is it starts to get at the underlying biology of mucosal immunity, helping to understand how it relates to systemic serum immunity and the extent to which there's a common mucosal immune system across the body sites, so the nasals or the adenoids or the intestinal mucosae. This work also has broader applications to the development and use of vaccines against other mucosally replicating pathogens. So our primary tool for doing this research has been through something we call vaccine challenge studies. And the general idea is that we kind of piggyback on a randomized controlled trial. So you start off with a group of participants who are randomized to receive some different combination of a vaccine. So it could be OPV and IPV in sequential use. It could be kind of different combinations across the types of vaccines. They're then challenged with a live attenuated vaccine, which is a proxy for the wild poliovirus infection. After they've been challenged, we can collect mucosal specimens, typically stool samples, and we can look at transmission using the proxy measure, which is the amount of vaccine virus we can recover from those samples. We can also directly look at some of the markers of mucosal immunity. And so we can look at mucosal neutralization of luciferase labeled pseudoviruses, as well as binding antibodies. And so what this work has shown is, first of all, so one of the major findings is that a single dose of an activated polio vaccine does not appear to inhibit viral shedding. And so if we look at this chart here on the right, the group on the left of the red box received TOPV, and then when they were challenged, only 2 of them went on to shed vaccine virus. In contrast, the group that received the trivalent IPV, many of them went on to shed vaccine virus upon challenge. What we can also see through this research is that the induction of the serum and intestinal mucosal neutralizing responses to polio vaccines are remarkably separate. And so on the left, we're looking at what happens if you kind of incrementally add doses of IPV. And so in the blue group, you have 1 dose of IPV, in the orange 2 doses, in the red group you have 3 doses. And you can see that the serum responses really follow in a dose-response way to the number of doses of IPV that were received. In contrast, though, that group that received 3 doses of IPV had very weak stool responses. And so in contrast to OPV, IPV has little effect on our intestinal mucosal neutralization. So another area of research for us was really trying to understand, well, what could be mediating this intestinal mucosal neutralization? And what we've consistently found across a number of studies in different geographies of the world is that it appears that there's this really close correlation between the immunoglobulin A levels and the mucosal neutralization that we can measure. And so this is a slide from actually a former Dartmouth undergrad's work, and so a really remarkable undergrad, Carolyn Strock. And I just wanted to kind of pause to say that one of the greatest joys of being someone who's been part of the Dartmouth community for a number of years now is having the opportunity to work with both undergraduate and medical students along the way, and to really see these young scientists be part of the research process and contribute. And so I wanted to highlight the work of Carolyn, which showed that active viral replication is actually a prerequisite for this induction of mucosal intestinal neutralization and IgA responses. So in the blue line was the group that had no detectable vaccine virus shedding. And we really don't see that neutralization kind of kicking in. In contrast, the green group, you see this robust neutralization occurring. And so I think there's always more to learn. And so the story's actually gotten more complicated. And so in new research that we're doing, we've started looking at different parts of the mucosal immune system. And so beginning to look at things like nasal wash and the adenoids and other things. And what we're seeing now is kind of completely different than the story that we were thinking in terms of the intestinal mucosal immunity. And so what we can see in new work from Audrey Godin, who's a research fellow in my team at the London School, is that the number of IPV doses received, so if you've had 4 doses of IPV in the past, suddenly we're seeing that in your nasal mucosal immune system, we're seeing neutralization is present, which is actually really exciting when we think about kind of the future of the global polio eradication initiative. And we also see that in contrast to the intestine, we see a close correlation between the systemic immune responses and the mucosal immune responses in the nasal wash. So much more to learn on this. And so just as a closing thought, I really wanted to come back to the title of today's conference, so turning vaccines into vaccinations. I think this is particularly true and really relevant to the global polio eradication initiative. And so if we look at the map on the left, the areas in light blue are places where we have truly concerning gaps in our 3rd dose vaccine coverage of polio vaccines. And on the right is a figure from unpublished work by Audrey Godin, that's looking at polio vaccine rates in Brazil. And so Brazil is a country that has benefited from tremendously high vaccine coverage historically, and decades of it. But if we look from 2010 to 2022, we see this persistent decline in immunization over time. And so we've made substantial progress towards global polio eradication, but in many ways, I kind of remain concerned that many of the challenges lay ahead of us. And for me, this really just reinforces the need for these interdisciplinary solutions-oriented approaches of having people from different disciplines come together to talk about how we're going to maintain vaccine coverage, really thinking about the immunology that goes into the development of more effective vaccines, and really how we can work together with partners from both academic and also within the pharmaceutical industry to kind of get the vaccines where they're needed. And so with that, I'll stop. Many thanks.